Hello and welcome to GonitSora.com. We are back with the fifth problem in the series Simple Concept of Problem. So this problem has been taken from the PRMO 2018 paper, and as we can see on the screen, the question is integers a, b, c satisfy a plus b minus c equal to 1 and a square plus b square minus c square equal to minus 1. Find the sum of all possible values of a square plus b square plus c square. Okay, so this is the problem, and let us see how we can deal with this problem, right? So in the solution we use these two conditions: a plus b minus c equal to 1, which gives us a plus b equal to c plus 1, and using the second condition, a square plus b square minus c square equal to minus 1, we can write a plus b whole square minus twice ab is equal to c square minus 1. Okay, and then using the first equation, equation number 1, in place of a plus b we can write c plus 1, and then after some simple simplification we get a plus ab equal to c plus 1. Okay, so we denote this by equation 2. So comparing 1 and 2, we see that a plus b equal to ab. Okay, now we need to remember that a and b are integers. Okay, so this makes our problem little bit simpler. Okay, so say if a is 0, then from the third relation we get b has to be 0, right? And if b is 0, then a has to be 0. Okay, so a equal to 0, b equal to 0 is a solution, and any other solution will require that a and b should be both non-zero. Okay, because if one of them is 0, then the other will be 0 because of this relation, the third relation, a plus b equal to ab. Okay, so we have already got one solution, that is a equal to 0, b equal to 0, which is a solution. And in this case, from the relation 1 we get c equal to minus 1. Okay, so one possible value of a square plus b square plus c square is 1. 0 square plus 0 square plus minus 1 square, that is equal to 1. Okay, now we need to find if there are any other solutions. Okay, so as I had noted earlier, other solutions, if any, of the relation 3 will require both a and b to be non-zero. Okay, so in that case we have a into 1 minus b equal to minus b, or you can write a into b minus 1 equal to b. And since a is non-zero, so we see that a divides b. Okay, because b can be written as a multiplied with some integer, so a divides b. Okay, and in the same way, if we take b to the other side, then we will get b into a minus 1 is equal to a. That means b divides, since a is b is non-zero, so b also divides a. So by the relations 4 and 5, what we have, a and b are integers which satisfy a divides b as well as b divides a. Okay, then what is the only possibility? The only possibility is that a is equal to b. Okay, so we have from 3, a plus a equal to a square, and this will give us a square equal to twice a, and this means that a equal to 2. Okay, so therefore b equal to 2, and the value of c is 2 plus 2 minus 1. Okay, that is 3. So another possible value, or the only other possible value of a square plus b square plus c square is 2 square plus 2 square plus 3 square, which is 17. Right, so sum of all possible values of a square plus b square plus c square is 1 plus 17. Okay, because the earlier possible value was 1 and the only other possible value is 17. Okay, so the sum of all possible values is nothing but 1 plus 17, that is 18. Okay, so we have seen that the concepts that were required to solve this particular problem was just the very basic concept of divisibility. If a divides b and b divides a, then a and b have to be equal. Okay, that was the concept required. We did not require any other tough mathematical concept. Okay, all others are usually done in mathematics classes, right? So this was our problem for this week. Next week probably we will be back with another problem which requires simple concepts, right? Thank you.